Let's discuss something interesting and very useful. Suppose if I ask you this question, what AWS services would you use to build a production grade microservice architecture and why? Don't answer it. Pause this video. Think for a moment. Not about how many AWS services you remember, but about how decisions a real system actually needs. Okay? Now come back. Let me walk you through how I think about this. Imagine this, you are not building a demo, you are building a real time system like real users, real money, and real failure at a 3 a.m. So, I don't think in a services. I will prefer think in a layers because production systems are not built with tools, they are built with decisions. So, let's think about the first decision. Where will your microservices run? Obviously, the compute layer. Most of the time, I choose Amazon ECS with Fargate. It runs containers, it scale automatically and remove the server management completely. If your organization is like Kubernetes first or needs some deep control, Amazon EKS is the right fit. It gives the full Kubernetes power with the AWS handling the correct plane. For event-driven or lightweight workloads, AWS Lambda shines well. No servers, install scaling, and pay only when your code runs. And what about EC2? Yes, it still exists, but in modern microservices, it is the exception, not the default. Now, think about the second decision. How does traffic flow? And answer is API and a communication layer. Amazon API gateway becomes the front door. Every client request always go through the Amazon API gateway, and this handles routing, throttling, authentication, and versioning. Inside the system, application load balancer distribute the traffic between the service efficiently. And when the system grows complex and failure becomes normal, AWS App Mesh add retries, traffic flow, and secure service to service communication without changing the application code. Now, let's move to the third decision. Who owns the data? Yes, the data layer. In microservices, this rule never changes. Each service owns its database. For a transactional data, Amazon RDS or Aurora provides a reliability and strong consistency. For massive scale and low latency, DynamoDB delivers the serverless performance and it is best fit for it. And for files or object storage or backups and even event triggers, Amazon ES3 is the backbone. And for the speed, caching, session, and rate limiting, ElastiCache keeps latency low. This is how you scale the system and teams independently. Now, fourth decision. What happens when something fails? I will prefer the asynchronous and event layer because in production something always fails and Amazon SQS decouples services so one slowdown doesn't bring everything down. SNS fans out events to multiple consumers, and EventBridge connects the microservices through business events, not tight coupling. And when data needs to flow in a real time, Kinesis handles high throughput streaming. This is how the resilient system survive traffic spikes and partial outage. Now, the final decision, which is very important. How do you trust your system? There are few points like observability, security, and DevOps. This is where demo fails and the production succeeds. CloudWatch gives a log, matrices, dashboards, and alarms. And AWS X-Ray shows the full request journey across the services. And IAM enforce the least privileges, security by design. And secret managers and parameter stores keep the credential out of the code. CI/CD with the code pipeline, code build, and code deploy ensures safe and repeatable releases. And AWS config keep the system compliant and governed. AWS has like hundreds of services, but production grade microservices are built with a small and intentional set. If you understand these five layers compute, communication, data, messaging, and observability you can design systems that are scale resilient and interview proof. And more importantly, they work in the real world. If this helps, you see AWS microservice as a decision, not just a services, then this is a video worth sharing. because real architecture aren't memorized, they are designed. Thank you, and I will see you in the next one.